never given this presentation and not had more questions than we could answer. So I'm expecting that. So I'll just dive right into it. So just a little bit of background. I have basically spent my whole career in this area of internet identity. It's been a problem since we started the internet. That's why we're working on it. There's a workshop, a conference called the Internet Identity Workshop that's actually been going on for 15 years, twice a year. And I've been to every single one of them since it started, and I've worked on internet standards in these various organizations. And the hats I wear at Evernym, I'm the CTO is actually Chief Trust Officer. We have a separate Chief Technology Officer. And at the Sovereign Foundation, one of the founding trustees, I'll explain more about Sovereign here in a minute. I chair the governance framework working group there, and you'll see the role of governance in this infrastructure we're talking about. A lot of folks don't know that the foundational standards in this space, a lot of the funding for the early work came from the U.S. Department of Homeland Security, and for D IDs, decentralized identifiers, and decentralized key management. And the DID spec that I was the original author of that spec, is now at W3C as a full working group. We're about halfway through, and I'm one of the editors of that spec there. So that's just a little bit of background. Now, again, I want to make sure it's clear. Evernym is a commercial vendor in the SSI space. Everything we're building is on this trusted RP stack that I'll be explaining. We helped write the original code base that's now at Hyperledger for what's the Sovereign. It's a global public utility for self-sovereign identity. It is literally a blockchain that's specialized just for the purposes of SSI, and that's an international nonprofit that was started almost 3 years ago. Actually, it was started almost 4 years ago. The blockchain's been operating for 3 years in July. So and again, I have been a trustee there, and I chair the governance framework working group there. But that is a separate, entirely separate, nonprofit organization. And then this Evernym contributed the original code for the Sovereign blockchain to the Sovereign Foundation. Shortly after that, Hyperledger had grown up to the point at the Linux Foundation. Brian Bellendorf became the executive director there, and he has a long history actually in identity. So the Sovereign Foundation said, let's contribute that code base to Hyperledger, so it would be part of a larger open source community developing blockchain. And I have a picture here of what they call the Hyperledger greenhouse, all the different projects at Hyperledger. Again, Hyperledger is well known for Fabric and Sawtooth as whole blockchain operating systems that have been developed there. So the contribution that came in from the Sovereign Foundation was, again, Hyperledger Indie project. And that was 2.5 years ago. The interest then in blockchain-based identity and the growth of that project led to two more. The crypto that was there, the zero knowledge crypto for credential exchange, then became the heart of a shared crypto library for all Hyperledger projects, which is called Hyperledger Ursa. That's now again shared by all the projects, so they're concentrating on one shared crypto library. And then the need to build on top of that, the higher layers of what you'll see in the Trusted RP stack led to the Hyperledger Aries project, and that's where the portable digital wallets and agents are now. So those are the three projects at Hyperledger that are where much of the implementation work is going on, at least in one technology stack. And the standards coming out of that, the specifications that are not already in standards bodies are what we're now standardizing at the Trusted RP Foundation, and I'll explain all of that. So again, that's just some background information. First, I want to tackle, so what is what is SSI about? Why is there so much interest in this new identity model? And I always start out by trying to explain this new identity model is actually as old as the wallets and credentials that we are carrying around with us to prove our identity every day. I hold up the physical wallet. And I like to say this is decentralized identity. The credentials we carry in this wallet, there is no one authoritative issuer that everyone has to go to. There is no single tree. Anyone can be an issuer of credentials. Anyone can hold those credentials if they qualify for them, and then we can go to any party who needs to verify our identity or some aspect of it. We call them a verifier, and they can verify. They can decide which credentials are they willing to take, and what do they do to verify them. If I want to go in and have a you know, a loyalty card at the coffee shop, it's pretty low level. But if I want to go get it on a plane, I have to have certain credentials, and they have to not be expired. They have to meet the verification tests of a TSA agent in the U.S. And yet the whole system it works. And of course, we take it all the way up the international passport system, in which all the governments around the world are collaborating. So it's a very well-known model. It's decentralized. It's as strong as it needs to be, and there is no, you know, one centralized authority. What we don't have a way of doing is doing this on this. We don't have a digital equivalent, or we have not had a digital equivalent until the emergence of this technology for how could we do credentials online. And that is what this whole thing is about. Now, at the heart of that is what's called the trust triangle. Again, this is both how physical credentials work today and how digital credentials work. They all have issuers. The credential is issued to a holder that keeps it in some form of a wallet. Now we show a person here, but a holder of a credential can also be a business or organization. You think of corporate registrations, the many certifications that corporations have. Those are all credentials for an organization. And of course, things, right? The MOBI initiative and vehicles, anything attached to the Internet of Things can have credentials, either if it's something like you know, a vehicle that can actually contain computing devices. It could actually physically have the credentials on board. But everything else, we're working closely with one of the trusted by a few members is GS1, the global authority for supply chains, barcodes, RFIDs for the things that we all deal with in commerce. All of them can have credentials associated with them. If the thing itself can't have them, then it's a digital twin that will actually be holding the credentials. And then the holders of those credentials present what we call proofs of those credentials anytime they need to be verified. Just the way you would, if you want to go rent a car, you're going to have to show the credentials that they need there or get on a plane. And when you think about presenting a digital credential, if you make this whole thing digitally, you actually, everyone who's gotten on board a plane using a mobile boarding pass has done exactly that. But what you've done is you've presented a specialized credential, a proprietary credential to the airline system, and you've used a proprietary wallet on most smartphones. It's Apple Wallet, Google Wallet. They're there. They work with a limited set of credentials designed for that, but they're not open standard systems. You can't replace that wallet with another wallet. You can't put any credential from any issuer in there. They have to be designed for those proprietary systems. What we're designing here is open standards for the issuance, holding, and verification of those credentials. And to make it all work is this magical piece in the middle called the Verifiable Data Registry. That's where blockchain and distributed ledger technology plays a role, and I'll explain that in a little bit more detail in chapter 2. But this is the basic trust triangle, and again, this is why physical credentials work today and work everywhere in the world in a decentralized system. What we're doing is adapting all of that using cryptography and you know, internet protocols, cloud, and smartphone to put it together so we can make it work digitally. Now, I'm going to give you a specific example that's been in the press quite a bit recently. This is a CoinDesk article from last month, actually, I guess 2 months ago now in April, about with the COVID situation. It suddenly a lot of light bulbs went on throughout in various different governments, healthcare facilities. oh, we've been hearing about digital credentials. Could we produce them quickly for COVID-related use cases? Somewhat unfortunately, the press decided to dub that the immunity passport, which generated a fair amount of controversy in terms of that name, and was the science far enough advanced, and was this going to lead to digital exclusion for people who didn't have smartphones? And I immediately want to point out, wait a minute, it's just like physical credentials. Anything you can produce with a physical credential, you can do with a digital credential. You can just do it faster and more easily, more securely, and more privately. But the two are not mutually exclusive. If you don't have access, then you can do it with a conventional printed credential. It just doesn't have some of those features. But in any case, it provided a very clear picture, and it's given a big boost suddenly. Projects that Evernym was working on that had more of a 18-month to 2-year time frame, that we're now working with healthcare providers to bring credentials to market in 30 to 60 days. So it's really moved very quickly. This is some of the text from that. A initiative started throughout the SSI industry that now has, at the time of the article, there were 60 organizations. There are now over 100 that are collaborating on what we call the COVID, the CCI initiative, COVID Credentials Initiative. And this is a list of the first 10, I believe it's up to 13 use cases now for COVID-related digital credentials. And again, some are more controversial than others. As the science advances, we obviously don't have a credential for vaccinations yet, but it's what everyone says we want. Once we have vaccinations, we're going to need to have credentials, being able to prove them. The one at the very top of the list, healthcare worker mobility, is in fact the very first one. Is already being worked on at the NHS in the UK. And all that happened with COVID is it got accelerated. This is a little bit of press that started to come out. They are just starting to roll it out. Evernym is one of the vendors involved in working on this. There will be more press in probably the next 30 days, but I'm just giving you, again, this is the little information that is publicly out there. But I want to give you a very tangible example of, yes, there are real credentials in production, and we'll talk more about those as I run through my examples. So I'm going to stop there and just say, are there any high-level questions about the basic idea of verifiable credentials before we go on to the next chapter? Annabelle, I'm figuring you will let me know if there are any questions.
I don't see any questions in the chat, but someone did post that today the California House passed CAAB 2004, sets a minimum standard for privacy preserving verifiable credentials for COVID-19 related medical test results. That's in the chat there.
That is wonderful news. Myself and a few others have been serving as consultants on the drafting of that legislation. I knew it was getting close, and you made my day. And I'll say that behind the scenes, actually, several other governments were providing input, because that's the first legislation that is being passed that's explicitly about providing authority for the recognition of verifiable credentials, and it was, of course, to enable their use for COVID. So I'm thrilled to hear that. That's great news. So let's chapter 2. I want to dive down in. So what's the basis for how this works? And I think based on my understanding of MOBI, a lot of this will be very familiar. You'll look at it and you'll go, well, that is the kind of thing you're developing. And I think as you look at the whole of the Trust RP stack, you'll say, oh, everything MOBI is doing fits within this larger framework. And I think that's absolutely right, which is why I think it's highly complementary and should help where MOBI wants to go. So here again is the trust triangle, and a little bit more what I call the Tinker Toy format. So I can run through it just to make sure it's clear. So how does this actually work, and what is the role of blockchain? Why does that suddenly made this transformation into a decentralized verifiable credential model possible? So the first piece and the way it all ties together is issuers have use the blockchain. The primary role of blockchain or distributed ledger technology in this whole infrastructure is it is decentralized PKI, public key infrastructure. It provides a solution for how we can move away or lower our dependency on centralized certificate authorities as the roots of trust for trusting public keys. Since all blockchain is based on cryptography anyway, it was sort of a collective aha about 4 years ago. Wait a minute, we can now use blockchains as a way of verifying the public key associated with a party. We just need to give it an address on a blockchain that can be verified by someone that you give that address to. So you have the key generation actually takes place at the issuer. It typically in their wallet or whatever process they trust to do that. And then it is registered with. You don't go and ask for a public key, you register a public key using this new type of identifier called a D ID, decentralized identifier. This is the specification that's now a full working group at W3C. Again, it's quite mature. There are over 50 what we call DID methods, and a DID method says, here's a specification for how a DID works with a specific blockchain or system. And the generic term is a verifiable data registry, because you can write a DID method to work with any form of modern blockchain or DLT. They can work with distributed or decentralized file systems like IPFS. They can even work with distributed databases or things like Active Directory systems. Whatever your chosen verifiable data registry system is, you can write a DID method for it, and it allows for a standard way to again write this information, the public key and the other cryptographic metadata that are needed, in a way that it can be subsequently read and verified in this process. So that's the first step, and the issuer of the credential will do that. The credential now with the private key, what they're able to do is sign verifiable credentials that are issued to holders of those credentials and go into their wallets. And notice that part of the process has nothing to do with the blockchain. This all takes place off-chain. And again, any type of verifiable credential can now be signed that way. And then when the holder goes to a verifier and provides a proof of that credential, for instance, you're getting on a plane and you need to provide a proof to the TSA of a driver's license or a passport, you can present that proof exactly the way you would present a mobile boarding pass today with a QR code that's scanned. That proof contains the DID of the issuer, so the verifier is then able to obtain, read from the blockchain, the public key and the other metadata that's needed to now verify that proof. And that's how you know that the proof is, the data has not been tampered with. It actually came from the issuer. It has not been changed at all. And lastly, there are a lot of questions. Can you revoke a digital credential? And the answer is yes, you can do that. It's not done with a public key. It's done with a different form of cryptographic proof that's on the blockchain. That's not, you can't look at that information and learn anything about the holder or what credential's been revoked. But in the proof that's given to the verifier, you can have a proof that it's not been revoked, and that can be verified, again, using the data on the blockchain. So you get near real-time revocability of verifiable credentials as well, which is something we don't have with physical credentials. The most important thing about this is not just that it's decentralized, but that this whole trust triangle works without any integration between verifiers and issuers. A credential issued, a passport, a driver's license, employment credential, a student ID, can now, any verifier that says, I trust that issuer, I have no relationship. I'm not integrated in any way with that issuer, but if the verifier trusts that issuer or some of the claims or attributes in that credential, they can now make trust decisions on the basis of that without any integration here, which if you're familiar with federation protocols, they all require that integration. And this is why we're breaking away into a whole new paradigm that's broadly known as decentralized identity. So let's run through an example here, the one we talked about before, this doctor's passport, just to drive this home. How is this actually being implemented by NHS today? So the issuer of that is the UK NHS service. They have written their DID and with a public key to the sovereign blockchain. Again, it's been operational, as I said, for nearly 3 years now, so it's in production usage. They then use that to sign what they're issuing is a doctor's passport, and they sign that with a private key. The holder of that credential is, in fact, a doctor or a nurse that needs to be able to travel quickly and between multiple NHS facilities in the UK, which has become a real pain point for having to move to the hotspots for COVID treatment. The doctor now can present a proof of that license to the verifiers there are the hospitals or treatment facilities. And again, the DID in that is then read the public key off the blockchain. This whole process, it's down to just a couple seconds, and it will verify that. And then, of course, because it's NHS and it's a known issuer of that credential, it's able to say, yes, I trust it. The doctor's through a process that can take up to 5 hours of paperwork. The NHS, their own study said that the adoption of digital credentials just for healthcare worker mobility would save 44,000 doctor hours per year. And that's not just a cost saving, it's time that doctors and nurses can actually spend on healthcare instead of paperwork, improving paperwork. So that's a really, tangible example of how this can work. Again, I'll stop there and say, any other questions about that process that have come up?
Drummond, we have a couple questions.
Sure.
First is, will we have multiple DIDs for different types of identity verification? For example, one for TSA, but a different one for hotel reservation and so on.
Yes. I'm about to actually, I'm going to answer that question in the next chapter here. And it's, I think it'll become very clear, because what I will say is, one of the powerful things about DIDs is because they don't, because they are generated by what we call the identity holder. They don't require going to a centralized registry or any cost or friction involved with that. Every party can have as many DIDs as they need to have what we call contextually dependent identity. So you can separate out, especially for individuals, the identity you need to share in a specific context, the set of credentials you need to share in a specific context. Now, for issuers of verifiable credentials that need to be widely known and verified, public entities, companies, governments, NGOs, they're going to want to have public DIDs. They may want to have more than one. They're able to separate them as needed, but they need to be widely verifiable, whereas individuals have the opposite need. They need to not be correlated unless it's required. So we can move away from our most correlatable identifiers in modern society today. We worry about our governmental identifiers, things like social security numbers in the US. Those have paled now to the to how you are correlated by your mobile telephone number, which you generally, now once those became portable, we use those almost everywhere. That's why websites ask for that information now. Your email address, even if you have several of them, they're easily correlatable everywhere you use them. Even your IP address as you roam the internet. These are highly correlatable identifiers, which if we want to have privacy by design, we actually want to move away from reuse of highly correlatable global identifiers into contextual identifiers, where we just use and we're known in a certain context, and that information cannot be easily correlated. And we have the computing infrastructure to do it. What we haven't done is the conscious design to do privacy at that scale. And that's what this supports. So that's probably a longer answer than you were looking for. I'll say more about it here in a minute. Go ahead. Were there other questions?
Thank you. Yeah, we do have other questions, but in the interest of time, I'm going to ask that you move on.
Good. Okay. Some of them I'm pretty certain we'll get to. So I do want to talk about the special role of peer-to-peer connections in this same diagram. Now, I pointed out that issuers have public DIDs in order that their digital signatures can be widely verified. But as I was just saying, what holders, particularly individuals, what they're able to do is, as they establish what we call connections, and here's an example. When the holder first goes to an issuer to say, okay, I qualify, I'm a doctor, and I need to be issued a verifiable credential for my license, that connection actually also uses DIDs, standard DIDs, but a different method called the PeerDID method, in which the two parties are they're generating key pairs and exchanging DIDs just with each other. They do not go on a public blockchain. In fact, they don't need to be shared with anyone else in the world. But what that's established is a persistent connection, a private channel between those two that can be used for any form of messaging or data exchange between those parties, that can be secured by their respective private keys, authenticated by the respective exchange of public keys, and continued to be reused literally forever. It is a unique connection between the two of those that there is no intermediary in that connection. There's no service provider or social network or registry that's needed to establish that connection, and the two parties can keep it for as long as they want. And again, B2C, C2C, B2B, and anything out there, those connections. So when the holder then goes to the verifier and there's a relationship to provide this proof here, another separate PeerDID connection is created. And since almost all of us will play all three of these roles, whether it's individuals or organizations or connected things, it's this web of PeerDID connections we're creating that is going to provide so much of both the security strength, but also the privacy for us to have these interactions without the kind of surveillance situation that we're living in with the current web. So I wanted to make sure that was clear and reinforce the point that holders, especially individuals, do not need to have public DIDs and can keep their relationships private, even if what they're sharing over these connections are verifiable credentials to prove things about their identity that are from issuers that have public DIDs. So I'll stop again and just see any questions about that specifically. If not, I'll move on to the next chapter, Annabelle.
So I think you don't have to address it now, Drummond, but at some point, DIDs on-chain and GDPR, how do they conflict, or how do they harmonize together? I think at some point we want to address that.
That is such a wonderful question. The Sovereign Foundation, the Governance Center Working Group, spent a year answering that question. I counted as the year of my life spent on GDPR, and not in any negative way. There was a lot of, blockchains, immutable, public. It almost seems like the polar opposite of GDPR. I'm going to give you a one-sentence answer, which is, as long as you separate out the purely public information from the private exchange of information, there's not a problem with GDPR compliance with this whole infrastructure. Getting to a deep legal answer on that was what we spent, and with about 65 stewards of the Sovereign Foundation, and they contributed legal resources. IBM actually led that group. I give them a lot of kudos. There's a whole white paper published on that topic, the Sovereign Foundation. You can find it if you just Google Sovereign, S-O-V-R-I-N, data protection. and you'll go straight to that page. It explains it. The web page gives a high-level answer, and then you can read the white paper. But it does go deeply into, if you make the proper separation between the public information on the chain and the private information exchange off chain, you can be fully GDPR compliant. In fact, I think, really be a stellar example of how to do GDPR at scale and with strong security and privacy. All right.
I have one
Oh,
question
go
here
ahead.
that just came through.
Sure.
You mentioned a vehicle having a wallet for verifiable credentials. Would the software of the vehicle control the connections and the proof presentation to other agents? How do you see the relation to the owner or other responsible party also having credentials about that vehicle?
Yeah, that is a super excellent question. I think the short answer here is the individual, say it's the owner of the vehicle, will have multiple wallets on multiple devices, and they will be able, to the extent that the owner wants, be able to share credentials, and the owner can present proofs as needed from any of those. So, and I have some diagrams coming up here that show a vehicle with a wallet is an extension of the set of wallets that an individual would have. So a credential could be issued straight to that wallet. That is, for instance, the registration of the vehicle, but that wallet is still under the control of a identity holder, is the term we use, and so access to that wallet and presentation of that wallet is still going to be controlled by the individual. If the individual wants to delegate to the agent in that of that wallet in the vehicle to be able to, for instance, automatically provide presentations or proofs under a set of policies that agent is following, such as tolls or parking, and just not be bothered. That's totally under the control of that owner, and they can just establish those policies with that wallet, and they can take care of that. I hope that starts to answer that question. It's a pretty deep one.
Thank you. I just want to mention that Mike put a link in the chat so people can refer to that. Let's move on.
Excellent. Okay. So there's one more thing before we get to building the stack that I want to make sure is clear, and that's the special role of governance frameworks. So one of the classic questions about the trust triangle is, well, how do you scale it? How are verifiers supposed to know all the issuers they can trust? And the short answer is you add another trust triangle we call the governance trust triangle, and it is when it's the role of a governance authority that will publish a governance framework. Almost always is a publicly available document. It doesn't have to be, but I literally don't know of an instance so far where a governance authority is not publicly publishing it, very much like governments publicly publish their laws. And of course, governments are one of the best examples of governance authorities, but I like to reinforce they're hardly the only one. In this infrastructure, any party, typically it will be an organization of some kind, but it could even be an individual, but can publish a governance framework that basically establishes the policies for how this works, meaning what issuers are authorized to issue what credentials to what holders that verifiers can rely on. And I want to reinforce again, just like credentials are not a new notion, neither are governance frameworks. The largest trust networks in the world work this way. I'm going to give you an example of MasterCard is a governance authority. The issuers that it authorizes are banks and financial institutions and credit unions, which issue a credential today. It's called a credit card, and it goes to cardholders, and cardholders can present proofs of that card to merchants in order to authorize payments. When you look at this overall trust triangle, it's pretty clear why MasterCard is one of the founding members of the Trust over IP Foundation, because MasterCard says, wait a minute, we've got this network. Why are we not using this architecture for being able to, for verifiable credentials to be able to prove trust and not just payment, because the two things do tend to go fairly closely together. So this diamond is now, I'll again reinforce, let's take the example of the doctor's passport that we used before. Here's how NHS is actually scaling this. They are the governance authority. The governance framework is actually in law and policy that they're publishing. What they're enabling is all of their 2,500 hospitals are going to be enabled to be issuers. They're all going to have DIDs on the sovereign ledger. And that's how they will be issuing the credentials to doctors and nurses. And they're providing the proofs, again, to other hospitals and facilities within the system, so that the entire ecosystem is, that's what we call it, a digital trust ecosystem. So again, I want to reinforce any group can be a governance authority. Now, the third obvious example is MOBI. What you're doing is creating a digital trust ecosystem. An example of that, and I don't, I'm no MOBI expert, but certainly car manufacturers could be enabling their dealers when they're actually selling a car to provide verifiable credentials for the vehicle, which then can be presented both manually or automatically to any verifier that needs to have to do that. Of course, that is one of the main propositions, right in the video of your website. So I think, again, that's why what we're doing here is a superset of what MOBI is trying to go after. So that's the role of governance frameworks. I like to reinforce this final point. Any digital credential that's going to be used at any breadth outside of just a single issuer and verifier is going to have a governance framework as the flip side of the coin. Just like your credit card only works, not because it physically works, but because of the whole trust network that's behind it at MasterCard or Visa. So with that, I can finally get into the last section. I'll stop again and just ask, are there any questions before I go into the Trust OIP stack?
I don't see any questions in the chat, but I'll give the opportunity to anybody that does have a question. Anybody?
No
All right,
problem.
let's move on.
Yeah, I think these final sections probably elicit much more. So, having explained all sort of the core elements, when the question came about, okay, so how do we make this globally interoperable, sort of achieve the same kind of ubiquitous adoption as we have of physical credentials today? John Jordan at the who leads the digital trust team. It's actually been renamed the Digital Trust Service at the province of British Columbia in Canada. Canada has been a world leader in digital identity for a long time, and I think of BC Gov as sort of the digital identity think tank of Canada. They're constantly leading in new innovations. And he coined the term, the Trust over IP stack, for this stack that was emerging from these new open standards. And this is a quick overall picture. I want to explain that as I go through this, you can look at it in this quadrant. First thing you'll notice is it is not just a technology stack. It is we call it a dual stack. It is a stack of governance frameworks that correspond to the technology that's needed. And it's a 4-layer stack. The first 2 layers are about establishing technical trust, also called cryptographic trust. And then we layer over that, the top 2 layers are about how we establish human trust that's rooted in that technical trust. And what's emerged out of this is, with these 4 layers, we can produce complete, full infrastructure that is as interoperable and can lead to the same ubiquitous adoption as the TCP/IP stack did for the internet. And that's why John coined that particular term. Now let's just go up. I'll quickly cover the layers of the stack. Layer 1 is it's the blockchain or distributed ledger portion. We refer to these as public utilities. Again, this is about publicly verifiable DIDs for any entity. Mostly it's going to be for issuers of credentials, again, so they can be widely verified, but it's also for the other cryptographic metadata that will be needed by the higher layers. And while we don't think there'll be thousands of these public utilities, there will not be just one. The sovereign network is being followed. Other Hyperledger Indie networks are now getting prepared to come to market. They just have different governance or economic models at this layer. There's one consortium IBM is leading called Bedrock. There are several national networks, one in Finland, a couple in Germany, and in the EU. Canada is now talking about their own. And those are just Hyperledger Indy based. You can also, of course, have permissionless networks. Microsoft has a technology called SideTree that runs on top of Bitcoin or Ethereum or other permissionless networks to add DID methods that can be used with those blockchains. All of them public utilities. All of them have some form of governance. The Hyperledger Indy public permission-based networks have specific governance frameworks. The best known is the Sovereign Governance Framework. Again, if SOVRIN governance framework, Google that'll take you right to the homepage. It has 3 roles defined in it: transaction authors that initiate transactions, endorsers are the permissioning layer, and the stewards actually run the nodes of the ledger, and they have to be authorized to do that. So that's a public permissioned approach. Anything that works with the appropriate DID method can work here at layer 1. In layer 2, this is where we have the agents and wallets, that the goal is, again, with this architecture separation, agents and wallets that are open standard, they can accept credentials from any issuer and hold them and present them to any verifier and work with any DID method that is meets the requirements, the security and privacy requirements of the owners and of the higher layers. For this layer, we believe that there are not any established governance frameworks yet, but they'll be coming. The Sovereign Foundation is looking at just that, to establish those security and privacy and data protection requirements for the hardware and software providers of agents and wallets. Now, this layer, it's deceptively simple here, agent wallet connection. I want to turn around and show you a much richer picture of what you're looking at there, because I think it helps tie in, well, how does this apply to MOBI? So I want to point out, you've got end-to-end, you've got the actors at either end, and we've got 4 categories that the Sovereign Governance Framework recognizes in terms of 2 categories of legal actors, individual organizations, but then we even divide the things that could be represented, natural things and man-made things, like vehicles. Edge agents operate at the edge of the network. That's the safest place to generate keys and store them on the various devices. And they can communicate directly edge to edge using a protocol like NFC or Bluetooth, or they can communicate via cloud agents and wallets. Very much like email clients will then talk to email servers that will deliver messages to other email clients. Both configurations need to be supported. They're different use cases. So obviously with MOBI, you're talking about vehicles. When I talk about multiple wallets that need to interoperate on behalf of the identity holders, that's across this set. And we would see the vehicle as another wallet that, again, can communicate inside this infrastructure. I will pop up that one of the most frequent questions is, well, if you're keeping credentials and keys on edge devices, isn't that quite vulnerable? And the answer is, you're going to have architectures like what we were developing with the DKMS work for DHS, where backup and recovery is automated using the cloud, encrypted backups in the cloud. And there are various recovery techniques that this architecture makes possible, offline and social recovery. I don't have time to go into those here. But on the Sovereign website, you will find a link to a 70-page report coming out of that DHS work on DKMS that you can take you very deep into that. So that's a deeper dive again into layer 2, what's behind that. But the important thing is interoperable, portable credentials and wallets for any device that needs them, for any identity holder that needs them. That's what supports layer 3, which is the trust triangle. Now we can have issuers issuing to holders, proving to any verifier, interoperably the same way browsers and any browser should be able to talk to any web server today, but with the whole cryptographic trust infrastructure behind it. There, the governance frameworks become very clear. They are what we call credential governance frameworks, similar to what exists for like the MasterCard or Visa system, where they define what are the credentials, who are the authorized issuers, what are the policies for issuing or revoking those credentials. And lastly, that all of this then supports the application layer. And what you have there is you have entire, we call them digital trust ecosystems. And that's where you get governance frameworks that cross multiple authorities, multiple credential types, but put them together into an interoperable ecosystem. So for a consumer or a business that's a part of that, it becomes much easier to understand. There might be a trust mark associated with all of the issuers and credentials within that ecosystem. From my perspective, MOBI is a textbook example of putting together that ecosystem, perhaps one of the richest ones in the world for enabling mobility. And I assume, you know, it's not for any one nation or you know, business. It is a digital trust ecosystem that I think fits perfectly into this overall part. And I think, let's see, is that, I have this one last slide here on the stack to just make sure that it's clear. These are, at the Trustworthy Foundation, we are basically standardizing, hardening both the governance stack and the technology stack. We don't produce any governance frameworks and we don't produce any technology. It's just to standardize it. And it becomes a tool for trust communities of any size and the governance authorities. They start with what are their requirements. We suggest they then design their governance and the policies they need and the governance frameworks they need at the appropriate levels. Then that finally translates to the technology they need to implement them. And that's our key goal. So my last slides are about the Trustworthy Foundation. I'll stop here quickly and say, any questions about the stack? I know there's a lot of information there.
Drummond, I have a couple questions here in the queue. First one is, do you have any information on the use of OpenID to authenticate SSI DIDs?
Fantastic question. OpenID being what I call the leading web scale federation protocol is, there's some very broad, wide deployments of OpenID and other potentially even larger ones coming. Some of them have become Evernym customers because the whole question has been, how can we take OpenID federated identity infrastructure and start to add or layer on verifiable credentials in the trust over IP stack? The short answer is that's exactly the way it should work. If you have an OpenID infrastructure, you should be able to add support for verifiable credentials. And there are two overall architectural approaches to doing that. There are two ways. One is there's an OpenID protocol called SIOP, Self-Issued OpenID Provider. It's not very well known or used. Microsoft is promoting using it to basically as a way to tie verifiable credentials into an OpenID ecosystem. The other one was not just pioneered but implemented in open source by BC Gov, which is to basically have an agent at layer 2 that speaks OpenID on one side and verifiable credentials on the other. It literally is an OpenID gateway. And they not only architected this, but then did an RFP for an open source implementation from a company that was won by a company called Matter in New Zealand. The whole thing's been implemented, and they have it in production in BC. They're using it, so they have verifiable credential. You present a verifiable credential. It looks to the end user like you're just you're scanning a QR code and hitting approve in your wallet. And what's produced on the backside is an OpenID assertion that the backend consumes just as if you'd used OpenID through a web page. So I think that's the answer I would give. Is it's going to all of Trustworthy infrastructure is going to be layered on. In fact, there is already a proposal at the Trustworthy Foundation. We're only 6 weeks old to create a task force inside that for OpenID compatibility and integration. So I think it's going to be a very, very rich subject. It's going to get a lot of attention.
One more question for your thoughts.
Sure.
TC 307 defines identity in 4 domains: natural persons, legal entities, things, and processes. What's your opinion on the gap here?
I think we're very close to that. In fact, if I went back, I will go back to this. I have to back up right there. Okay. So we said natural persons, organizations, and what were the other two?
Things and processes. Drummond, this is Dan. So the major difference is processes, where you might have a process sequence that is unique, like a version, a software revision. So in TC307, we want to uniquely identify that process that was used in this, right?
Absolutely. So even though it might not look like it, again, what you're seeing here is the taxonomy from the sovereign governance framework. But in our explanation, if you go in and read that, we made this division between natural and man-made things because there's a legal distinction in many jurisdictions. Some natural things have rights. Besides animal rights, there's actually a river in New Zealand that is a legal entity and protected that way. Processes, be they logical processes, whether it's software or digital files or anything, those are all we put under the category of man-made things. So as I think Dan knows, you can give a D ID to literally anything that has identity of any kind. And that's how you can integrate 100% of those things into the trusted OIP stack. So I think we should be fully compatible with that, that ontology. Does that help, Dan?
Yep, thanks. Yep. So a process is a man-made thing in this. Yep, got it. Yep.
I can absolutely have a DID, and in fact, I don't have time for it, but I was just exposed yesterday to call it cutting edge call center technology, where DIDs are going to be generated dynamically for every different interaction that you want to have a private connected channel for. And so I think the use of DIDs we're seeing only the tip of the iceberg right now.
Thanks, Drummond. Thanks, Dan. Let's move on. We only have a few minutes left, and I want you to be able to finish your presentation.
Good, and I'm almost done. So the last part here is I just want to, folks, now that I've explained the stack, and thanks to Dan, Accenture is one of our founding members. We just launched the Trusted OIP Foundation as independent project Linux Foundation in the first week of May. So we're about 6 weeks old. We started with 29 founding members, and we just passed 80. So it's been growing very rapidly, and it's as we explained, it's all about how we are going to fully define and harden the stack. These are 2 slides of our steering members, and IBM, MasterCard, MITRE have been very involved in this. SICPA, I love to point out, is one of the world authorities on, they print much of the digital currency and passport technology used by governments for physical credentials. And so now they're saying, hey, we got to be able to do the same thing for digital. These are a number of the contributing members. So the purpose of the Trusted OIP Foundation, its relationship to all the others working on components of this infrastructure is to bring it together into this interoperable stack that is not just technology, but also governance. So that's why we'll be working closely with all of these organizations. Just for folks to understand, we have 2 working groups on the technical stack and the governance stack, but we also started 2 what we call Foundry working groups that are specifically for communities in practice, for those starting utilities at layer 1. As we said, they're now 8 or 9 that are actively in gestation, coming to market, and then ecosystems at layer 4. That's actually our largest working group, because anyone like MOBI that's saying, hey, we're creating one of these, we want to get together, understand others, figure out how we maximize synergy, develop best practices together. That's what it's all about. And that means there can be projects at any of these 4 layers, and you can host those projects anywhere. Again, this is a tool, but we're seeing the Linux Foundation says, hey, any governance authorities that want to come and develop at any of these 4 layers, you're welcome to do it there, or of course, any place. You already have an established consortium, so you're all set up for that. But think of Trust over IP as a tool for you to use to help achieve your objectives, and I think that's what I've got. We're after a trust layer for everyone. So, final questions.
Yeah, thanks, Drummond. This is great presentation. I think overall, we see a lot of momentum within the community, MOBI and the blockchain community at large, moving towards DIDs and DIDCOM and VCs and so on. So I think that's encouraging, and I think that's exciting. So one question for you, especially for this audience, which is the mobility audience, if you were trying to set up or erect an ecosystem, a network that allows vehicles to be autonomous or semi-autonomous agents, right? To process transactions, pay for infrastructure, negotiate right away, and so on and so forth. How would you set this up to allow the vehicles to do that? And also discover services and at the same time be discovered as a potential service, right?
Yeah, I said it earlier, and as I was preparing for this presentation and reading up on MOBI, it just kept reinforcing in my mind. You are the canonical example of a digital trust ecosystem that needs all the richness and all the power of the trust over IP stack. I mean, you've already made, I think, tremendous progress in doing that. So my first recommendation is start to think in terms of an ecosystem governance framework, because the hardest part will not be the technology. I know that's it's not all of those challenges have been solved, but I think we're well along on that. But it's the coordination and the trust infrastructure so that the wallets in all the vehicles, the owners of those vehicles and controllers of those wallets, and the issuers of those credentials and the verifiers that they all need to be buying into and agreeing to an overall governance framework so that all the parties are trusting each other in these, what will end up being billions of interactions, right? I'm not worried about the scalability. If you follow the architecture we're talking about here, it can absolutely scale because many of the interactions are peer-to-peer, right? And you're not going to, I think you won't run into blockchain bottlenecks. But the challenge will be, how does everyone trust each other and allow these automated processes to happen?
So maybe more on the granular basis here, if we want to absolutely ensure discoverability, do you recommend putting vehicle DIDs on chain or no need, and just use off chain or peer DIDs?
I knew someone was going to ask that question. And I'm going to be careful here because the answer is I'm really not sure. As I was looking at your architecture for VIDs and thinking about it, I was really torn myself, because there are definitely cases where, just like the license plate on your vehicle is publicly available to anyone that needs it, for good safety reasons and law enforcement reasons. There are other cases in which your interactions with that vehicle, you want to be private, right? Being tracked everywhere you go in order to enable mobility is also a potential surveillance issue. And I know you must be struggling with this. So
yeah, well, outside of the technical and philosophical realm, the GDPR realm, right? Do you see any issues with vehicles having their own DIDs being on chain?
Yes, there definitely can be GDPR issues about that. And the reason is simply what we recognize or had to deal with the Sovereign Foundation, the answer I gave you earlier, and why I recommend reading that white paper, is that any identifier of any kind that can be associated with an individual, and of course, an identifier for a thing that can be associated with the individual is indirectly associated with that individual. And our feedback from the regulators that we talk to is absolutely those have to be treated as personal data under GDPR, which means if those identifiers are going on chain, they must be subject to, because if it's immutable, which the chains we're dealing with are, they must be subject to one of the exemptions under GDPR. And we talk about the 3 exemptions that we're preparing for individuals that cannot today write individual identifiers, individual DIDs to the sovereign ledger because of this concern about GDPR. We've put in place what we believe is a legal infrastructure and the legal agreements called the transaction author agreement to enable individuals to have that right once we can get comfortable that it's okay. But there's specific exemptions for a personal DID. I don't know if those same exemptions would apply to a vehicle, a VID. I'd be happy, it sounds like a deep dive topic that I'd be happy to have a separate call about, just because I want you to leverage as much of that year's worth of work that we did as you can.
Yeah, for sure. I think we'll need it. So we'll set something up. Thank you.
Excellent. Any other questions I can answer? I know we're probably getting a little over time.
Drummond, if I could, you said that the technology is not the issue. That's pretty mature, and I agree with that. That the governance is the tougher battle. But I do want to, and I've been involved with the MOBI folks for a while as well. And I definitely been championing Hyperledger Indy because that technology is mature, and there's so many things purpose built for identity. When you make the statement that the technology is there, are you thinking that, like, what if somebody says, well, I want to use Hyperledger Fabric, I want to use Corda, I want to use some other technology stack? Can you remind folks that trust over IP is based on RFC 289 from Ares? Can you talk to that at all?
Yes, and I want to be clear. When I said that, what I wanted to make it clear, and Dan knows this as well as anyone, which is I don't think technology is going to be the long pole in the tent. I don't want to communicate, hey, the whole technology stack is done and we have it all out there and implemented in production, because we don't. We have key pieces, but you're very right, Dan, that in that RFC, that is the basis. It's currently Hyperledger Ares RFC because we had to start the Trust OIP Foundation before we can move it over and make it an RFC that's natively from us. But it is our formal definition of the stack and of the 4 layers and the requirements of the 4 layers. And I would say that we could go layer by layer and actually talk about where we are. Dan brings up a very good question. Currently, Hyperledger Indy is optimized, and the DID methods to talk to Indy-based blockchains, yeah, that's pretty mature. Like I said, those are in production. But there's still evolution. Like, as I said, revocation, high-speed revocation is still something we call it second generation. That's still in process. Adapting DID methods to other blockchains like Fabric, it's very clear what needs to be done. There are Fabric-based DID support, but it's not as mature yet. There's still work that I think needs to be done there. Adapting DID methods that are interoperable with the Indy ones for other blockchains. As I said, there are over 50 DID methods out there, but they're not interoperable to the extent they need to be yet. So there's still a gap there. We definitely have a gap at layer 2 in terms of the ability of agents and wallets to use any DID method interoperably. Today, they tend to be designed or optimized to use a particular layer 1 utility. So that we know that gap is there. We've got work we're consciously doing on that. Layer 3, there are currently not, there are verifiable credential exchange protocols, but they're like 3 different families of them, and they work with specific types of the verifiable credentials that are in the W3C standard. We need to harmonize those and get to interoperability there. And then layer 4, there's still plenty of work to be done as well. So that's a long list, but Dan, you're right. There is, we have, I think, very clear definition of the 4 layers, but work to do at all 4 layers, still on the technology side as well as governance.
Drummond, I know we're a little bit over, but I have one last question. I think it's an easy one. My understanding is that Hyperledger Fabric is not necessarily immutable. Is Hyperledger Indy immutable?
The Hyperledger Indy chain is designed for immutability, yes. There are some extreme examples under the GDPR, as we did that assessment, we looked very closely at, would it be possible to prune transactions, for the right of erasure or right to be forgotten that's talked about. And it is theoretically possible. It's practically going to be very difficult. So the design, of course, is for the transactions to be immutable, which is why anything you want to be able to erase, you want to do off-chain. You want to root it and digitally sign it with the immutable information on-chain, so it can be verified for as long as it needs to be. But the actual transaction or exchange, that's why we show all those happening off-chain, because every one of those private peer DID connections, either party can simply say, I'm done, delete, and give a cryptographically verifiable and auditable instruction to the other party, the data controller, delete. And so both sides of the connection can be deleted and meet the right of erasure.
Thank you. Drummond, thank you again for all your valuable time and sharing your knowledge. I got a lot of comments in the chat saying this was a fantastic presentation. I think our audience enjoyed it and learned a lot. We also recorded the presentation and have your blessing to post it on our website, so thanks for that. And before I end the call, I just want to let everybody know that our next lecture is going to be on Wednesday, July 8th, and we will publicize the lecture through our bi-monthly bulletin and social media channels, so be on the lookout for those announcements. Thank you again, Drummond. Have a beautiful day, everybody.
And thank you.
Thank you.
Yeah, thank you so much. Excellent.